Okay, example 1. A newspaper reported the following measurements in different stories. The distance from Earth to Moon is a very large number. A worm measures a very small number. For each measurement, state a more appropriate SI unit and explain your choice. Okay, so first of all, what the heck is SI unit? What is that? Metric. What does it stand for? SI. What is that? System International. Okay? It's just the international system. Okay, so a more appropriate unit for the distance from the Earth to the Moon. Why would you use centimeters? That doesn't even make sense. This is 38 billion centimeters to the Moon. Why would you do that? What's a more appropriate unit? For System International, you have to use kilometer, not mile. Mile is imperial. Okay? So kilometer for the distance Earth to the Moon. And then a worm. Why would you use meter for a worm? That doesn't even make any sense. So what's a better one for the worm? Yep, centimeter or millimeter would be perfectly fine. And then convert the given measurement to the more appropriate unit. Okay, so this 38 billion into kilometers. That's our job right now. You got to use this chart, okay? This chart here. The metric number line chart. So all you have to do is count the jumps, and the jumps represent the factors of 10. That's why metric was built. So it's easy, factors of 10. All they do is slide the decimal. Okay? So how many jumps from centimeter to kilometer? 5? 1, 2, 3, 4, 5. Yes, 5 jumps. Everyone see that? I'll do it once. 1, 2, 3, 4, 5 jumps. Unit got bigger, number gets smaller. So we slide the decimal to the left. 1, 2, 3, 4, 5. So it looks like 38, 4, 4, 0, 3. So it looks like a comma would go there. So 384,403 meters. So you got to see in here the 5 decimal moves. 1, 2, 3, 4, 5. So the decimal is right next to the 3. And then you can write the number and then split the number into groups of 3 so you can read it. 384,403. Okay, and the other one? Meters to what? Meters to centimeters? How many jumps? Are you new? Yeah. Go grab a book and go sit over there and grab a blue book. Can you just grab a blue book for him so he knows which one it is? Yeah. And it looks like we're on page 6 doing metric conversions. Okay, so we got meter to, what is it? Centimeter, meter to centimeter. How many jumps? Oh, and this time we're going down the chain. So the unit's getting smaller, so our number should get bigger. So this time we slide the decimal not to the left but to the right. So we got 1, 2. So the decimals are on the left of the 1 there. So it's 0.19 centimeters. So it's not even a full centimeter. So do you think centimeter was the best choice? Millimeter is the better choice. So we can go. I've lost my pen tool. What's going on here? Lag. That's what's going on. 1.9, right? 1.9. It's showing up here. Stay with me and watch what happens. Kilometer to meter, 3 jumps. Number gets. Why does the number get bigger? Because the unit got smaller. Good. So how many decimal moves? 3. So how many zeros do I add? So right now it's 30. So you need 3 more zeros. Good. 30,000. 3 jumps. Next one, centimeter to kilometer. How many jumps? Centimeter to kilometer, that's 5 jumps. Unit is getting bigger, so we got to get smaller. So 5 jumps. It's all going to go all the way to the front, right? So 0.42307. Number 2 is glorious. It's so easy. 1 jump, right? So is it 27 or is it 0.27? Like, which one do you pick? Yeah, 27. Because the unit gets smaller, number gets bigger. And then DAM, which nobody in society uses ever. It's the decameter. Okay, the decameter, the hectometer. I think the hectometer is used a little bit, but very rare. And the decimeter, never. These are just placeholders, really. Okay, because when it's so small, they want to use these 6 places. Like I said last day, once you get smaller than the millimeter, it's 3 jumps. So another 1,000, and then the next one would be micro. And then after micro would be nano. On the bigger scale, think about computers. 3 jumps from kilo is kilobyte. What's the next one? Megabyte. That's what like I used to have on my old MP3 player. I could get like 15 or 16 songs on there. 64 megabytes. Okay. Then nowadays it's like gigabyte, right? So another 1,000 megabytes, you get your gigabyte. And then bigger than giga is tera, yeah, and that's for like the servers. Like a Google server would have like thousands of terabytes. Okay, so the DAM, it's rarely used, but we're going to just, it's like on a test just so you can see if you know how to do metric. So how many jumps from DAM to KM? 2 jumps, unit's getting bigger, unit got bigger, so our number should get smaller. So this is 0.407. Okay, can you guys finish the next 4? Quick, quick, quick. Okay, next page is the next dimension, if you will. So if you look at my whiteboard, a straight line is 1 dimension, okay? When you add another dimension, you have to go perpendicular. This is area. This is like a piece of paper. 2 dimensions, okay? This is what we call square units. Okay, so if we wanted to go from centimeter square to meter square, we have to do something a little bit different. And then more is the next dimension. 3D, this is an extra dimension of depth. This is like our world in here. And if we wanted to go to centimeters cubed to meters cubed, it's a little bit different than what we're used to. Okay, so it's the same process, but instead of doing factors of 10, it's factors of 10 square if you're doing square units. If you're doing cube units, it's factors of cube units. Okay, so what you're going to do is on top of the page on example 3, you're going to jot the number line in. What goes in the middle? Meter. Now let's go to the right. DAM. Bigger on DAM is HM, and the biggest is KM that we're going to have on our tests. Before the middle, smaller than the middle, is DM. This is deci. One smaller is centi. The next smallest is milli. Okay. Now it's the same process where you count the jumps. So centimeter to meter, how many jumps is that? 1, 2. Unit got bigger. So do we divide or do we times? We divide. Unit's getting bigger, so our number has to get smaller. So we divide by 10 squared, we divide by 10 squared. Normally it's just divide 10, 2 decimal moves. But because it's square units, you have to do it 10 square. So it's the exact same thing, except you double it up. So if the number's 3, like this, every jump would count as 2. So 1, 2, that's the first jump. 1, 2, that's the second jump. Okay, so you have 0.0003. So centimeter to millimeter, how many jumps is this? Centimeter to millimeter. There's only 1 jump. but it's worth 2, remember, because it's square units. So it's going to be 2 decimal moves, and all we have to decide, does it go to the right or to the left? Units getting smaller, so our number should get bigger. So 2 decimal moves to the right. So this is 270. And I'm just going to do some volume ones now. Okay, let's do number 7. Oh, 7. Look, it's the exact same. So 7's for free. Let's do number 4. Meter to decimeter. How many jumps is that? Only 1 jump, but it's worth 3. Good. So, and then we have to decide, does our number get bigger or smaller? Well, a unit got smaller, so it should get bigger. How many jumps? 1, 2, 3. Because each jump is worth 3. 4,700. So try 8. Try 5 and 8. Then we move on. Okay, question 5. How many jumps on the line? Centimeter to meter. Here, I'll change color pen. How many jumps from centimeter to meter? 1, 2. So for this one, 2 jumps on the line, right? And when you have squared units, each jump is worth 2. So that's 4 decimal moves. Centimeter to meter, the unit got bigger. Good, so unit bigger, number smaller. So we'd move the decimals to the left. Good. It's 4 times. 1, 2, 3, 4. 4.2. So there's like a lot of steps, but you have to think about it sequentially. And if you ever want to do a science program, metric conversions have to be a must. And if you can do the linear ones we did on the last page, you'll be fine. These square ones, cube ones, I wouldn't worry too much about. Okay, we'll do one more, we'll move on. Millimeter to centimeter, how many jumps on the line? 1, and each jump is worth 3. 1 jump equals 3 moves. What would 2 jumps equal? 6 moves, and so on, right? But we're not going that route. 1 jump, 3 moves. Now, you pick. Is it 0.305 or is it 305,000? There's only 2 options. The unit got bigger, so which one do we pick? The smaller number. Okay, the next thing on our agenda is the imperial system. The imperial system, we're talking about, what's the smallest? Imperial for length. Inch. It's the size of your, no, thumb. Good. Pinky is the centimeter. Good. Thumb, and then your foot, and then if you walk, yard, and then if it's football fields away, it's mile. Good. Okay. So that's the imperial march. And now I wish I had the Star Wars theme playing right now. The imperial march. Okay, are we flipping the page or what's on the bottom there? Okay, if it's kind of weird looking in the photocopy, it's on your yellow sheet, so don't stress out about that. Here we have a polar bear. The photograph shows a polar bear, and it gives you a scale 1 to 24. It says calculate the height of the bear's back to the nearest inch. What is the length of the bear? Well, I don't have a ruler. Maybe I have a ruler. Cool. Okay. What do we want? The height of the bear? So how am I going to turn this thing? I don't know. How do you turn my ruler? Oh. Oh. Look at me. Technology. Okay, height of the bear. See the thing on the right there? What is that? Is that inches or centimeters? What's bigger? The thumb is bigger than the pinky, right? So which one's on the right here? That's your inch. And it's broken into these little chunks. So like this is your half inch. This is your quarter inch. This is the 1/8 of an inch. This is the 16th of an inch. So if we were to do inches, I would count by 16s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 sixteenths. Well, that's just 1 inch. 17 sixteenths looks like 18 sixteenths, and you know it's like 18.5 sixteenths, which is bizarre. That's why we don't use imperial all the time. It's weird. Metric looks nice. What's metric? 3.1 centimeter. Everyone see that? So I think metric is the best way to go. Like if you're in a physics class and you're to measure something and then do a distance time, you would definitely use metric. It's way easier because you can just use the precision of the metric units. Okay, so to the nearest inch wants us to the nearest inch. So do you want to just use 1? Nearest inch. Let's just use 1. Keep this simple. Nearest inch. Okay, so the height is 1 inch. And you guys know that the inch is the double tick, right? Okay. And then what is the length? Okay, so now I got to turn this, get my ruler going again. Come on, ruler. Turn the ruler. Grab the ruler. Grab the ruler. Okay. And now we do the length to the nearest inch. So looks like what? 2? Can you see that good on my screen? Looks like 2 inches. Okay, so 1 by 2. That's pretty easy to do. Okay, let's get rid of this ruler. Hide the ruler. Look at this. This is beautiful. Length is 2 inches. Okay. Now, it says, here's the scale, 1 to 24. So, how do I use my scale? Well, for scale, it looks like this. Model goes first, original goes second. So, the model is 1, the original is 24. So, if this is 1 inch in the model, then what would you times by? 24. So this is, in actuality, 24 inches. And this one would be times by 2 times 24 would be 48 inches. Okay? And those are perfect factors of 12. So the height is 2 feet and the length is 4 feet. Groups of 12. 12, 24, 36, 48. Groups of 12 is your feet, and we'll get into that in a second. Okay, converting imperial measures. So there's 12 inches in the foot, there's 3 feet in the yard, there's 1,760 yards in the mile. Completely random. The word is arbitrary. It's just a random number that makes no sense. Arbitrary. Just pick a number, whatever. Now I'll show you the technique. The technique that I'm going to use is called unit analysis. Unit analysis is used in Science 10, so then we can all be consistent in the math and in the science. In the Dash 3, you might have, if you've taken that course, you might have seen cross multiplication, which also works. Okay, so you can use cross multiplication if you already know how to do that. However, I want to teach unit analysis, so let's take a look. With unit analysis, you always times by a conversion factor. And it comes from the formula sheet, okay? That yellow sheet on the front chart, that's where it comes from. Don't use your textbook chart, don't use a phone, don't use, so that we're all consistent using the yellow sheet. Okay, so first one, you have 4 feet. You don't want feet, you want inches. So what we do is we times by a factor, and it's a ratio. So draw in a bracket, draw in a ratio line. We want feet to go away, so we put feet in the bottom. We put feet in the bottom. What's happening here? Technology. Okay, here we go. Feet in the bottom. And what goes in the top? Inch. You want inch. So that goes in the top. Now you need the relationship between inch and feet. What is it? In every foot there is 12 inches. So put a 1 down here and a 12 up top. 12 inches for every foot. The feet cancel. Anything in the top you times, anything in the bottom you divide. So 4 times 12 divided by 1. This is basically 4 times 12. You get 48. And I apologize, I'm having some issues with the tablet, and I'm going to fix it in just a second here for the next one. Okay, 4 yards into feet. So we have 4 yards, and we're going to times by something. That's a ratio, so that yards goes away. Yards is in the bottom, and what goes in the top? Feet. So that way the yards cancel, and you're left in feet. So now all you need is the relationship. In 1 yard there is 3 feet. So times by 3 divided by 1, it's just going to be 4 times 3, which is 12. Now we're going to do mile to feet. So 1 mile, oh, it tells you right here. It's 5280. So why is 1 mile 5280? 12 inches, good, times 3 yards times 1760. Inch, feet, yard. And that should be 5280. Or no, is it? What? Times these two, what do you get? Yeah, 5280 from that one. But is 5280 on the yellow sheet? Yes, so that one's for free. Okay, now let's go mile to inch. So you start with 14, mile. Do they give you a direct conversion to inch? You got to go yards first. So this is one of those where you have to do 2 steps. It's a 2-stepper. Okay? So I'm looking at my yellow sheet. I'm on the top of my chart. I found mile, and I can get to feet with 5280, right? So let's get to 5280. So how do I do that? I want mile to go away. That goes in the bottom, and I'll put feet up here. So in 1 mile, there is 5280. Now times again, because now I'm in feet. I'm in feet now. The miles has canceled. Now I just want inch. So how do I get to inch? Well, I need feet to go away. So what do I times by? In the bottom has to be feet, because then feet will cancel. And then I put inch in the top. Now I need the relationship between inch and feet. In 12 inches there is 1 foot. Or 1 foot there's 12 inches. So this is what you would do. 14 times 5280 times 12. And that's going to give you how many inches are in 14 miles. So it's a very large number. Can someone do it for me? 040? Anybody disagree? Okay. Well, that makes sense, right? 14 miles. How many thumbs can you fit in 14 miles? 887,000 apparently. Okay? So this is unit analysis, and you just times by a conversion factor so that the units cancel. Okay, so these ones are for free. So 12 inches is 1 foot. 1 mile is 5280. These are just from the chart. 3 feet is exactly 1 yard. And 1 yard is exactly 3 feet. And because there's 12 inches in every foot, you have 36. 1 yard is 36, and that's also on your formula sheet. So those 4 came for free. Your first assignment, okay, this is your homework, and then once I feel like you guys are ready, I'm going to give you quiz 1.